Hello guys, welcome back. Today we're going to continue to talk about testing hypothesis when the population standard deviation is unknown. We already saw the critical value method, so we're going to look at the p-value method using the TI-84 plus. Okay, so we're going to illustrate this using this simple example right here. The mean height of women in Texas is 59.3 inches. In a sample of 52 women between the ages of 60 and 80, the mean height is 60.1 inches, and the sample standard deviation S is 4.2. Okay, we want to know whether the mean height hue of for older women is more than the mean height of all women. The alpha level is 0.05. Okay, so the first thing we want to do is to state the appropriate null and alternative hypothesis. The null hypothesis is mean 0 is equal to 59.3. The alternative hypothesis mean 0 is greater than 59.3 because we are having the sample mean here greater than 59.3. Okay, so we're going to compute the test statistic. Of course, this is going to be done using TI-84 plus. We're going to state the conclusion. Okay, so if you scroll down, you will see the steps that will be taken. You go to start, go to test, go to t-test, and select start and enter this info in the TI-84 plus. So let's go right there. I'll turn the calculator on. We'll go to start and we'll go to tests, and we're going to select number 2, which is the t-test. Again, we're using t-test because we do not know the population standard deviation. Instead, we're using the sample standard deviation. Okay, so we'll select number 2 and select start because we already have the numbers we need, the values, the null mean, the sample standard deviation, and all that. If we are using a table to get this information, we use data. So starts. So we go to mean 0 is 59.3. The sample standard deviation is 4.2. The sample mean is the sample mean is on top. Sample mean is 60.1, and then the sample standard deviation is 4.2, and then the sample size is 52. Okay, now we're going to go down and select the type of test. This is a one-tailed test and this is a right-tailed test because we are in our alternative hypothesis. We said that the null mean is greater than 59. Okay, 59.3, and the reason is that the sample mean is more than 59.3. Okay, so we select that right-tailed test right there, and then we are going to calculate. Okay, so when we calculate, this is what we have. Okay, first you can see that the alternative hypothesis is saying that the null mean is greater than 59.3. Then we have the test statistic, that's T, 1.37. Okay, and this is our p-value, 0.88. That's what we have right here, 0.88. That's the p-value. Okay, so since we are using the p-value method, we're comparing that with the alpha level. The alpha level is 0.05 and the p-value is 0.088. So because the p-value is more than the alpha, we fail to reject the null hypothesis. Okay, now remember, every time you have a p-value that is more than alpha, we fail to reject the null hypothesis. If the p-value is less than alpha, we will reject the null. So what do we conclude when we fail to reject? There is insufficient evidence to conclude that the mean the mean height for older women is greater than 59.3. Okay, so if we were to reject, we'll say that there is sufficient evidence to conclude that the mean height for older women is greater than 59.3. So concluding is all about the alternative hypothesis. So you have evidence to support the alternative hypothesis, or you don't have enough evidence to support the alternative hypothesis. Okay, so that is how we do the p value method, test hypothesis using the p value method. Okay, again, when you do this on TI-84 plus, you have this output. Of course, with p-value method, you can look at p, compare it with the alpha level. Okay, the one above t is the test statistic. In case you are doing the other method, you compare the test statistic with the critical value. Okay, so that is what we have right now, talking about testing hypothesis using TI-84 plus and using the p-value method using the TI-84 plus when the population standard deviation is unknown. Okay, so next time we are going to start looking at the chi distribution. Thank you. Bye bye.